Hello maths fans! Welcome to a special Christmas themed edition of Tom Rocks Maths to celebrate Maths Week England. Now I love Christmas, but it is far too early to be getting festive already. I'm walking down Oxford High Street, the shops already have got their Christmas decorations out, there's tinsel, there's fairy lights, and you know what else is on display? Christmas jumpers. Now don't get me wrong, Christmas jumpers are a lot of fun, but they are the ultimate in one-use fashion. You buy one, you wear it to your school party, your office party, and it probably never sees the light of day again. And this got me thinking, what effect does a Christmas jumper have on climate change? Fortunately, the bulk of the calculation has already been done for me, courtesy of the charity Love Your Clothes. They estimate that around a third of the UK already own a Christmas jumper, and about a quarter of the population will go out again this year and buy a new one, spending in excess of £300 million. The Huffington Post took this one step further and calculated that Christmas jumpers bought this year will have an impact on the environment equivalent to 500,000 bathtubs full of water and enough carbon dioxide to fill 179 party balloons per person in the UK population. So, how much carbon dioxide and water is this equal to? The idea here is for you to pause the video, have a go at this calculation yourself, and then come back, resume, and I will tell you what I got, and you can compare this to your answer. Let's start with water. So if we have 500,000 bathtubs filled with water, we need to know the average size of a bathtub to convert that into an amount of water per bathtub. So in the UK, the average bathtub is 1.7 metres times 0.7 metres and is around 0.5 metres deep. So this is taking a bathtub to be a cuboid shape. So if I draw a diagram, our bath will look something like this. We're saying this amount is 0.5 metres, this amount is 0.7, the width and the length of the bath is going to be 1.7 metres. Now if we use these values, we will get some amount of metres cubed and we can convert that into litres per bathtub. But in a full-size bathtub, you can't fill the entire cuboid with water. There's actually some sort of bit around the edge, there's a thickness to the bath itself, and then in the bottom, often if you check your bath at home, there's a bit of a slope. So a bathtub of the standard or average size in the UK, 1.7 metres by 0.7 by 0.5, will actually hold around 200 litres when you account for the thickness of the walls and the fact that the bottom is sloped. So now we know the amount for a single bathtub at 200 litres, we multiply 200 by the number of bathtubs, 500,000, and that is going to equal 100 million litres of water. So 500,000 bathtubs full of water used in the production of Christmas jumpers each year is equivalent to 100 million litres. You can also convert this into another measure, for example, the amount of water required to fill an Olympic swimming pool, and this is equivalent to 40 Olympic swimming pools. So how did you get on? Maybe you got a different answer to me. You probably did get a different answer to me than the 100 million litres or 40 Olympic swimming pools that I've calculated here. Something that is worth bearing in mind is that a full bathtub can hold around 200 litres of water, but when you take a bath yourself, you're taking up part of the space within the bathtub, and you probably don't fill it right to the very, very top. So a common figure for the amount of water used when taking a bath is 80 litres. So perhaps you use that value in your calculation rather than the 200 that I've used here. So have a look at your own number, see how it compares to my 100 million litres. Did you overestimate? Did you underestimate? have a think and see if you can come up with a reason for maybe why you were slightly different to my answer. Next up, carbon dioxide. So we're told that the production of Christmas jumpers is equivalent to 179 balloons per person in the UK. So we need to know the UK population. In 2019, I'm going to say it's around 66 million. So we do 179 times 66 million, which equals 11,814 million balloons. Now that is some party. So we now need to convert 11,814 million balloons worth of carbon dioxide into an amount in, let's say, litres. So we need to know the volume of an individual balloon. So if I were to draw a balloon, sort of something like this, bit of a string coming down the bottom, tied at the bottom, this is a single party balloon. Now this is quite an awkward shape. So what I'm going to do in this estimation, because it is just an estimate or an approximation, is I'm going to say this is kind of the same as a sphere. Because a sphere, we know, well, we have a formula for calculating the volume of a sphere, and so we can use that to help us with our estimate and our answer. So if I take a balloon to kind of be the shape of a sphere, a standard party balloon has a diameter d equals 12 centimetres. So the volume of a single party balloon, again approximating as a sphere, is equal to 4/3 times pi times the radius cubed. So if the diameter is 12, that's the full distance across the balloon. Then the radius is half of the diameter, so the radius is 6, so times 6 cubed. Now, plugging these numbers into a calculator, we work out that the volume is 900 centimetres cubed, which is equal to 0.9 litres per party balloon. So finally, all that's left to do is to take the total number of balloons, multiply by the volume of carbon dioxide in each balloon to get our final answer. 11,814 million times 0.9, which equals 10,633 million litres. And if we compare this to our method of measurement for the water, where I converted the answer into Olympic swimming pools, we can do the same here, and 10,633 million litres of carbon dioxide would be enough to fill 4,253 Olympic swimming pools. Again, how did you do? What did you get in your calculation? Was it more or was it less than my 10,633 million litres of carbon dioxide? And just as before, can you pinpoint why our answers were different? As a final task, why do you think the statistics were presented in their original form in terms of the number of balloons of carbon dioxide per person and the number of bathtubs of water? And from that, why do you think I then presented my results in terms of Olympic swimming pools? What do you think is easier to process? Really big, horrible numbers or something a little bit more tangible? This was, of course, just a bit of fun, but it just goes to show that sometimes we can be very wasteful as a species. So this year, when it comes to choosing your Christmas jumper, why not recycle an old outfit and turn it into your very own personalised Christmas jumper? It not only looks great, but you'll be doing your part to save the planet too. Thank you very much for watching. Please do remember to subscribe and check out everything else that I do.